Welcome to my projectbazaar.com.
Now we discuss about the product for a multi-channel oscillator for a resonant chemical sensor system. Next we see the abstract for the product. The demand of microelectrochemical systems based minimized chemical sensor is continuously increasing the wide range of application because of their small size, low power consumption and CMOS compatibility. Potential applications span across many fields such as the industrial, environmental, medical, automotive and consumer applications. Micromechanical resonant devices that are based on mass loading effect are promising the platform of miniature of chemical sensor system. They offer superior sensitivity, high resolution and wide range application. These devices include thin film bulk aggressive resonator, surface acoustic wave, capacitive micro ultrasonic transducer and micromechanical cantilevers. Among these resonant sensors, the Siemens sensor is a promising platform for practical and versatile application because of its high mass sensitivity. It is multi-resonant array structure and high quality factor for chemical sensor system. Vapor detection usually high sensitive minimized resonance sensor is of greatest interest for many applications, including consumer, industry and environmental applications. An operational amplifier based on multi-channel oscillator that interface with 50 MHz capacitive micromechanical ultrasonic transducer array is presented for chemical sensing application. The circuit was implemented in C.18 micrometer CMOS technology and per channel. The presented integrated circuit addresses the potential frequency locking problem between the chemical by allowing by open loop gain to be adjustable off chip process. Next we see the flow diagram for the product. First, the voltage input is applied to our operational transconductance amplifier. This amplifying result to amplify the voltage input results and to conduct the operational transconducting performance for operating performance level. Then to amplify the voltage level and to get the high voltage for the processing for current buffer circuit. This current buffer circuit is mainly used to buffer the whatever the input to passing the output results for overall architecture. The buffer amplifier to be get the input to transfer the output side, but the same input to allocate for time allocation for using the buffer result performance level. Then to calculate the power comparison performance. This power comparison mainly based on our overall CMOS based circuit for operational amplifier and the operational transconducting amplifier and the current buffer circuit. This CMOS designed to optimize the power allocation and to perform the amplifying results based on our given input level of inverting the voltage level input and to pass the output result for get the voltage input and the current buffer circuit, then the power allocation for overall performance allocations. This voltage level process to implement the voltage input and to pass the buffer results based on our chemical based sensor schematic of two stage of ODTA system. Next we see the final output for the product. First the input voltage to apply the our required processing for inverting the our final results. Then to pass the our circuit allocation for amplifying and the buffered amplifier circuit. The buffer amplifier circuit mainly based upon the current buffer architecture process. Then to pass the amplifying results, the voltage to be applied for the voltage level and to pass the current amplifier result. These two designs are completed by the CMOS oriented process. Then the PMOS and NMOS combinations to be passing in the two step of circuits and to pass the final output results for to inverting the our input and voltage for given input signal and to get the final result for our buffer amplifying results. But we get this some time allocation for overall architecture process. This is our the sensing based on the overall CMOS design architecture for chemical sensor architecture. This is our the final out design for our the chemical sensor system. Then to allocation for time minimization for the overall current buffer circuit. This current buffer circuit mainly is to get the input and output for the same result, but needs get some time allocation for the mirror amplifying process. The amplifying result to increase the voltage level and to process based on the differential input voltage for our given input circuit. These output results to be passed on the output level and to get the CMOS based on chemical sensor system. Then to run the output for our the chemical sensor system. This is the time allocation for our timing diagram results for the chemical sensor based system. This is our design for overall process. Then to open the timing diagram. This timing diagram based on our input and output voltage printing voltage level. This is our the input and inverting input level for given voltage level. This is our the based on to increase the voltage level based on our the input to differential input and to get the current buffer circuit for some time allocation for overall architecture. This is our the time allocation for our the processing time. Then to get the final output result to process the our output results. Then to get the high performance for inverting the our overall result for our voltage differential input voltage architecture based on our ones and zero position for our the inverting voltage and the voltage input. Then to get the output voltage for maximum voltage level and to get the output voltage for another maximum voltage level for the next level to the differential input voltage for amplifying the result and to get the buffer amplifier result for overall architecture. This is our final timing diagram result for our chemicals based sensor system.